Hello, this is Ralph Tawil. This is my final project for multiphysics simulations. My project was the analysis of the relationship of input velocity to the equivalent stress of a consumer-grade automotive power shaft. The motivation in 1963, Chrysler made a car that used a jet engine instead of a combustion engine, but it failed because it's too expensive. And with modern technology and manufacturing, it might be possible to make it cheaper and actually work. Um, and I've worked in the past designing one of these things, designing the power shaft of one, and in the past in a different class. My hypothesis is that increasing the input velocity of the air will cause the shaft to undergo more stress. Uh, for the convergence part of the project, I modeled a simplified shaft, and uh, then found that the more detailed parts need to be at 2 millimeter element size, and the more largest parts need to be at 5 millimeter element size. For the second part of the project, I started with computational fluid dynamics. I used this power shaft, very simplified, even, and I found the and I did the and I found the flow of air over this, and how the pressure applied to the fan. And then I used finite element analysis to find the deformation and the von Mises. And then I did that for different input velocities. Um, this is the fluid results that I got. This is the path lines that the air comes in from here when made when it went over the fan. That's the back of it. You can see how the fan just moves all the air out of the way. These are the velocity vectors of this, and you could see in there how the fan moves the stuff away as well. And then this is the pressure on the fan. You can see how the pressure is only applied to the front facing of is higher on the front facing of the blades than the back facing. That should provide the torque that ends up causing the fan to do its job. Um, this is the results for the static structural analysis. These are where the pressures are, um, and these are where the deformations are. As you can see, the deformations are mainly at like the ends of the fan blades, which are to be expected because that's where the highest pressure is. Um, thank you.